Okay guys, here is our calcium homeostasis lecture. When we're talking about calcium homeostasis, we're talking about a main function of your bones, because it's very important that we keep our calcium levels in our blood steady. We don't want this to be too high, we don't want it to be too low, because calcium affects a lot of different functions in the body. It affects your neurotransmitter release. It affects how reactive your cells are, so how likely they are to have action potential. So thinking of your neurons, your muscles, things like that. So it can change how excitable those sorts of cells are. And it's also necessary for just general muscle contraction anyway. So we need for the calcium to be perfect. And not perfect, I shouldn't say perfect, but within a normal range is a good way to say it. So what we want to do is if it gets too high, we want to bring it back down, and if it gets too low, we want to bring it up. And we use the bones as sort of a storage place for calcium. When we have extra calcium in the blood, we can put it into the bones and store it there. And then when the calcium in the blood gets too low, we can pull it out of the bones using our osteoclast, which will then release that calcium back into the blood where we can use it. So how is this going to work? When the calcium in the blood is too high, so your plasma calcium, that's how you would refer to that. Calcium in the blood would be called your plasma calcium. Your thyroid gland is going to secrete a hormone called calcitonin. Calcitonin inhibits the osteoclast. It increases renal excretion of calcium. So what is this going to do? It's going to lower the calcium in the blood. It's going to stop your osteoclast from working, so they stop breaking down bone. And then it causes you to urinate away any excess calcium. So it's not going to directly stimulate your osteoblast, but it's going to keep the osteoclast from working against them. So those osteoblasts, while they're doing what they do, which is, putting calcium into the bone, they're not being worked against. So that's how calcitonin works. Now, for the opposite situation, when the calcium in the blood is too low, you want to raise it back up again. So we have our parathyroid gland secreting parathyroid hormone. And that's going to do a few different things. One, it stimulates our osteoclast, so it causes the osteoclast to work harder, so they're breaking down more bone faster than osteoblasts are building, so we're having a net loss of bone, which means you're releasing that stored calcium into the blood. It causes your kidneys to reabsorb calcium, so you don't urinate away any excess calcium. Causes osteocyte apoptosis, which we saw before when we were looking at osteocytes. So it's going to kill the osteocytes, so they're not there to maintain that matrix around themselves. And then the last thing it does is it stimulates an enzyme in your kidney tubules that helps you convert calcidiol into calcitriol. And I'm sure you guys will remember this all very fondly from that vitamin D3 lecture of how calcidiol is an intermediary product getting into calcitriol. And calcitriol enables you to absorb calcium from your diet. So that is an important way of bringing the calcium in your blood up as well. So these two things are working opposite to each other, calcitonin versus parathyroid hormone. And they're going to work to keep your calcium in your blood at a nice, happy, steady range where your body can function properly.